Rational numbers. In lower classes, we have seen about natural numbers, whole numbers, integers, natural numbers means starting from the countable numbers. It is countable numbers starting from 1, 2, 3, etc. This number is a natural number. Countable numbers are called natural numbers. Whole numbers, natural number including 0. Starting from 0, 1, 2, 3. These are called whole numbers. Integers. Natural numbers 0 and negative numbers. So this is called integers. Natural number is denoted by n. Whole number is integer denoted by w. Integers are denoted by z, and the numbers which will come in between two integers, okay, those numbers are called rational numbers. So this rational numbers is of the form p by q. P is an integer, q is an integer. Both are integers. P and q are integers. And the denominator does not become 0. Okay, so q not equal to 0. And the main important thing is p and q should not have any common factor. Other than 1. So those numbers are called rational numbers. Suppose 1 by 2. Here 1 is an integer, 2 is an integer. Both does not have any common factor. So 1 by 2 is a rational number. If we take 2 by 4, 2 by 4 both have common factor. So this is a fraction. It is multiples of 1 by 2. It is equivalent fraction for 1 by 2. 2 by 4, 3 by 6. These are all equivalent fractions. We can say equivalent fractions for 1 by 2. 2 by 4 is a fraction, 3 by 6 is a fraction, 1 by 2 is a fraction. But 1 by 2 only is called a rational number. Why? Because 1 and 2 does not have any common factor. 2 and 4 has common factor. 2 is an integer, 4 is an integer. 2 by 4 is a fraction. But 2 by 4 is not a rational number. 1 by 2 is a rational number. The same way, minus 1 by 2 is a rational number. Minus 3 by 4 is a rational number. Minus 7 by 8 is a rational number. Minus 100 by 3 is a rational number. Why? Because even though if it is having negative sign, the two numbers does not have any common factor. So those numbers are called rational numbers. 0 also a rational number. 0 divided by 1. Any number divided by 1. It is a whole number. We can put denominator 1. So 0 by 1 is a rational number. So 0 also a rational number. So rational number is of the form p by q. P and q are integers. Q not equal to 0. P and q should not have any common factor other than 1. Those type of numbers are called rational numbers. We'll see the properties of rational numbers. Properties of rational numbers under addition. Under addition. We'll see some of the properties. First one, closure. Closure property. What is closure property? If we take two rational numbers, suppose 3 by 8 and minus 5 by 7. Okay, 3 by 8 is a rational number, minus 5 by 7 is a rational number. If we add these two rational numbers, the sum, what we are getting, here there is no common factor. So, common table LCM is 56. So, 3 into 7 plus minus 5 into 8. It becomes, because 8 and 7 is a LCM, 8 7s are 56. So, here we need to multiply by 7, here we need to multiply by 8. So, 3 into 7 plus minus 5 into 8. 3 7s are 21 minus, plus into minus become minus, 5 8s are 40 divided by 56. It will become here 21 minus 40. So, the greater number sign is minus 19 by 56. So, 19 and 56 does not have any common factor. So, minus 19 by 56 is a rational number. So, if we add two rational numbers, the sum become rational number. So, rational numbers are closed under addition. If we take rational numbers A and B, if we add both the rational numbers, the sum become a rational number. Okay. So, A is a rational number, B is a rational number, A plus B also become rational number. So, it is closed under addition. Second property, commutative property. Commutative property of rational numbers under addition. Commutative property of rational numbers. These are all properties of rational numbers under addition we are seeing now. So, this is commutative property of rational numbers under addition. Closure property of rational numbers under addition. Next we are seeing commutative property of rational numbers under addition. Commutative means exchanging of numbers. If we take two numbers A and B, so A plus B equal to B plus A. If it is proved, then we can say rational numbers are commutative under addition. That means two numbers we are taking. The two numbers, if we exchange and add, the sum should be equal. That is called commutative property. Let me take this same numbers 3 by 8 plus minus 5 by 7. So, if we add, the same number will come now. So, 56, 3 into 7 plus minus 5 into 8 equal to 21 minus 40 by 56. This will become minus 19 by 56. If we exchange the numbers, that means if we write minus 5 by 7 at first plus 3 by 8, here also LCM is 56. Here we need to multiply by 8 and here we need to multiply by 7. So, minus 5 into 8 plus 3 into 7 become minus 40 plus 21 by 56. It will become, the greater number sign is minus, 40 minus 21 is 19 divided by 56. We are getting same answer. So, if we exchange the numbers and add also, the answer becomes same. The answer is same. So, A and B are two rational numbers. A plus B equal to B plus A. It is satisfying. So, 3 by 8 plus minus 5 by 7. We are getting minus 19 by 56. Minus 5 by 7 plus 3 by 8 also we are getting same answer, minus 19 by 56. So, rational numbers are commutative under addition. Next we will see about associative property. Associative property of rational numbers under addition. Association means gathering, grouping. Next property. Property of rational numbers under addition. Associative means grouping. So, if we want to group, the number should not be 2 or 1. If we have more numbers only, we can group. So, we will take 3 numbers, A, B and C. So, A is a rational number, B is a rational number and C is a rational number. So, that if we group A and B together first, and if we add C, otherwise A will keep separately, B and C we will add first. So, these two should be equal. This is called associative property. A plus B will add first. With that answer, with that sum, we are going to be adding C. This side, RHS side, B and C we are adding first because bracket should be removed first now. So, B and C should be added first. With that sum, we are adding the number, rational number A. So, if we are getting the sum on both the sides, LHS and RHS are equal, then we can prove rational numbers are associative under addition. Let me take 3 rational numbers, minus 2 by 3, 3 by 5, minus 5 by 6. We take 3 rational numbers. We will take LHS first. A plus B plus C. So, A and B will add together first. Minus 2 by 3 plus 3 by 5. These two will add. With that sum, we are adding minus 5 by 6. So, what will happen in this bracket? The denominator is 3 and 5. The LCM is 15. So, with this we need to multiply by 5. Here we need to multiply by 3. So, here we need to multiply by 3. So, 5. So, minus 2 into 5 plus 3 into 3. It will become minus 10 plus 9 by 15. The greater number sign is minus 10 minus 9 is 1 by 15. Minus 1 by 15. So, along with this, we need to add minus 5 by 6. Here also we need to add minus 5 by 6. So, here also it has to come minus 5 by 6. Thus, the sum of these two only minus 1 by 15. So, minus 1 by 15 plus minus 5 by 6. So, these two we need to add now. So, here 15 and 6 if we take 15 and 6 if we take LCM, third table 5 times and 2 times. 5 2s are 10, 10 3s are 30. So, LCM is 30. So, with 15 we need to multiply by 2. With the 6 we need to multiply by 5. So, that here also by 2. So, minus 2 plus minus 5 into 5 become minus 25. It will become minus 27 by 30. So, minus 2 by 3 plus 3 by 5 plus minus 5 by 6. So, first we will add this bracket with that answer. We are adding minus 5 by 6 also. So, what we are getting? Minus 1 by 15 plus minus 5 by 6 become minus 27 by 30. So, this is our left hand side answer. Now, we will find the right hand side answer. Right hand side is, first number will be separately, minus 2 by 3 will keep separately, plus 3 by 5 plus minus 5 by 6. So, what we do to first number we keep as it is, minus 2 by 3 plus second number 5 and 6, the common LCM is by 6 are 30. So, here we need to multiply by 6 and here we need to multiply by 5. So, that here 6 and here 5. So, 3 6 are 18. Plus into minus become minus 5 5s are 25. So, what will happen? 7. So, minus 7 by 30. So, one of the side we have. So, the first number we are keeping here separately. So, minus 2 by 3 minus 7 by 30 become, here we can take 30 as the LCM. We need to multiply by 10 here. So, multiply by 10 now, minus 10 to 20 minus 7. That means it will become minus 27 by 30. See here, RHS also minus 27 by 30. LHS also minus 27 by 30. So, rational numbers are associative under addition. Next we will see about additive identity. What is the identity for rational numbers under addition? Identity means if we take any number, if we add something, we should get that same number. So, whatever the number we have taken, if we add 0, we will get the same number. In natural number also, whole number as well as integers. So, this same will be applicable in rational number also. Suppose minus 2 by 7 is a rational number. With this, if we add 0, it will become minus 2 by 7 again. So, the 0 is the identity under addition. Identity means it is making the same number as the answer. What number we have taken, that same number become the answer. So, that the 0 is the identity. Inverse. What is the inverse of rational numbers under addition? If we take minus 2 by 7, so with this, what number if we add, we will get identity. So, identity under addition is 0. Under addition, identity is 0. So, the number and its inverse, if we add, if we get that identity, so that this number is the inverse of that given number. So, with this, what number if we add will get 0? So, here minus 2 by 7. If we take plus 2 by 7, what will happen? LCM is 7 minus 2 plus 2. Minus 2 plus 2 becomes 0. 0 by 7 become 0. So, we are getting answer 0. So, for minus 2 by 7 plus 2 by 7 is the inverse. Suppose if it is minus 2 by minus 7. For this, what is the inverse? Plus these two signs itself will get cancelled. So, we have to put one more sign. So these two sign is cancelling. Minus 2 by 7. That means minus of minus 2 by minus 7 is the inverse. Is the inverse of minus 2 by minus 7. If a number is not having any sign, suppose 2 by 7, for this inverse will be minus 2 by 7. We don't need to put sign on both sides. Only one sign we have to include it. If there is no sign also, or if it is having one sign also, if it is having one sign, if we include one more sign, so these two signs become positive. So plus 2 by 7 we are adding. Minus 2 by 7 plus 2 by 7 become 0. Minus 2 by minus 7 plus minus 2 by 7 become 0. So for this minus 2 by 7 is the identity. So inverse. For 2 by 7, inverse is minus 2 by 7. Next we will see properties of rational numbers under multiplication. First we take closure property. So what is closure property? We take rational numbers, two rational numbers A and B, so that A into B also become rational number. If A and B are rational numbers, A into B also become rational number. We are seeing properties of rational numbers under multiplication. So we have to use multiplication symbol. A is a rational number, B is a rational number, so that the product also become rational number. We need to prove this for closure property. Suppose let we take minus 2 by 3 into 4 by 5. Okay, so if we multiply, what we get? Minus 4 2s are 8 divided by 3 5s are 15. This is positive sign, so plus into minus become minus. Minus 4 2s are 8 divided by 3 5s are 15. So minus 8 by 15. Minus 2 by 3 is a rational number. Plus 4 by 5 is a rational number. The product minus 8 by 15 is a rational number. So proper rational numbers are closed under multiplication. Closure property. Rational numbers are closed under multiplication. Second one, we'll see about commutative property. Commutative property of rational numbers under multiplication. So for commutative means exchanging of numbers. So if you want to exchange, we will take two numbers, two rational numbers A and B, so that A into B, we have to prove that B into A. So we have exchanged now the numbers. First we are writing A as the first number, here B as the first number. So if we exchange and multiply also, the answer should be equal. That is called commutative property. So commutative property of rational numbers under multiplication. So let me take two rational numbers, minus 7 by 3 and 6 by 5. Okay. So if we multiply minus 7 by 3 into 6 by 5. What will happen? 7 and 5, it is not possible to cancel. 6 and 3, it will go in same table. So this is in multiplication. All the numerator we can write in numerator. All the denominator we can write in denominator. We no need to take LCM. So minus 7 into 6 divided by 3 into 5. Even this 6 we can write as minus 7 into 6 we can write as 2 into 3 by 3 into 5. So this 3 will get cancelled. The remaining will be minus 7 2s are 14 by 5. Now we'll take RHS. What is RHS? We need to exchange these numbers. 6 by 5 we have to write at first. Minus 7 by 3 we need to write next. So these two numbers we need to multiply. So multiplying, we'll take minus 1. Minus sign is there. So we'll put at first. 6 into 7 divided by 5 into 3. So here 5, 3, 7 are prime numbers. We cannot simplify more than this. So 6 we can write as 2 times 3. So minus 2 into 3 into 7 by 5 into 3. 3 and 3 will get cancelled. Minus 2 7s are 14 by 5. So LHS also minus 14 by 5 and RHS also minus 14 by 5. So what it is showing? If we exchange of numbers and multiply, the answer is same. So rational numbers are commutative under multiplication. Next we will see about associative property of multiplication. Third one. Associative property of rational numbers under multiplication. So association means grouping. We have to group numbers. So if you want to group, we need more than 2 numbers. So we'll take 3 numbers, A, B and C. A is a rational number, B is a rational number and C is a rational number. We are grouping now. So we'll group first A and B together times C, and RHS will be A will keep separately, B and C will group together. So A into B into C equal to A into B into C. So what number is inside the bracket we should clear at first according to board mass. So the bracket should be multiplied at first. With the product we need to multiply the number which is outside. So first we will take LHS. For this, let me take some numbers. Minus 2 by 3 is one rational number. 3 by 5 is one rational number. Minus 5 by 6 is another rational number. Let me take 3 rational numbers. So, according to LHS, first we will group first 2 numbers together. Minus 2 by 3 into 3 by 5 into minus 5 by 6. Okay. So, these 2 numbers are grouped together first. So, these 2 will multiply. So, inside this, what it is there? Minus 2 into 3 by 3 into 5. No need to multiply. We'll try to simplify it. If it is possible anything, we can cancel. Into minus 5 by 6. So here what is happening? 3 we have cancelled. The remaining will be minus 2 by 5 into minus 5 by 6. What will happen? This 2 and 6 we can cancel, or otherwise we'll write the numbers as it is. This minus into minus become plus. 2, this 5 are prime numbers. So 2 into 5 divided by denominator also on 5 is there. Into 6 we can write 2 into 3. This 5 will get cancelled. 2 and 2 will get cancelled. So all numbers got over. It is 1 time. This also 1 time. So numerator is 1 by 3. So minus 2 by 3 into 3 by 5 we multiplied at first. With the product we are multiplying minus 5 by 6 also. At last we are getting 1 by 3. Next we will take RHS. RHS is, will multiply the next 2 numbers at first. So minus 2 by 3. Minus 2 by 3 will keep as it is into 3 by 5 into minus 5 by 6. We are clearing at first. So what is inside the bracket we need to clear at first. So minus 2 by 3 will be there as it is into minus 1 minus is there. So we keep in front of 3 into 5 divided by denominator also one prime number into the 6 we can write as 2 into 3. So this 3 we can cancel. This 5 and 5 we can cancel. So what is outside? Minus 2 by 3 into, inside the bracket all the numbers have cancelled. So it is 1 time. So 1 and the minus sign also there. So minus by denominator is every number cancelled except 1. So except 2. So 2 is there. So what will happen now? We need to simplify this one. Minus into minus become plus and this 2 will get cancelled. The remaining will be 1 by 3. So RHS also we got 1 by 3 and LHS also we got 1 by 3. So associative property under multiplication we have proved. So rational numbers are associative under multiplication. Multiplicative identity. What is identity? If we take a number, it is under multiplication. So if we multiply any number, we should get the same number. In natural number, whole numbers and integers, everything, whatever number we have taken, if we multiply by 1, we will get the same number. The same format is here also. If we take minus 2 by 7 times what we multiply, we will get the same minus 2 by 7. It is nothing but 1. So 1 is the multiplicative identity. So the number what we have taken is minus 2 by 7. With that, if we multiply identity, we will get the same number. That is called identity. Identity means what number we have taken, the same number we should get after doing that operation also. That is called multiplicative identity. Next, inverse. Multiplicative inverse. If we take a number and multiply by its inverse, we should get identity. So what number is to be multiplied to get that identity? It is called inverse. So with A, if we multiply 1 by A, we will get identity. Because this A and A will get cancelled, we will get 1. So for A, 1 by A is the inverse. Suppose we will take a rational number minus 2 by 7. So minus 2 by 7. With this, what we multiply, we will get identity. So we have to write the inverse. Inverse means we need to write this A, we are writing as 1 by A. So this minus 2 by 7 we can write as minus 7 by 2. So for minus 2 by 7, minus 7 by 2 is the inverse. Minus sign wherever we can put. So minus 2 by 7, for this the inverse will be minus 7 by 2. So minus 2 by 7 into minus 7 by 2 become 1. So the inverse is the reciprocal. Inverse is also called the reciprocal of the given rational number.